Listen as an instructor leads a discussion on some material from an astronomy class.
Today, we're talking about the life cycle of a star. I hope you've all read that chapter because we're going to be talking about it today. First of all, where does a star get its energy? Sally?
A star needs hydrogen to exist. The hydrogen fuels nuclear reactions, and these nuclear reactions are the source of the star's energy.
What happens when a star begins to exhaust its supply of hydrogen? Rob? Maybe someone else could try answering the question. Doug, what happens when a star begins to exhaust its supply of hydrogen?
When a star begins to exhaust its supply of hydrogen, its life cycle is coming to an end. It becomes an old-aged star.
That's right, Doug. And what happens as a star heads into old age? Kathy?
The first sign of old age is that the star begins to swell and to turn red in its outer regions. It's called a red giant. This picture shows an example of a red giant. It shows a star that has swollen and turned red.
Now let's talk about our sun and see where it is in its life cycle. Is our sun a red giant? Doug?
Our sun is an average-size, middle-aged star. It's been in existence for about 5.5 billion years, and it will most likely become a red giant in about 5 billion years.
So, as a star ages, it begins using up its supply of hydrogen, and it swells and begins turning red. What happens when all the hydrogen is used up? Sally?
When all the hydrogen's used up, the star collapses and dies.
That's right. When its hydrogen is depleted, a star collapses. But do all stars collapse in the same way? Rob?
Yes, they do. They all collapse in the same way.
You sure, Rob? Maybe you'll want to read the assignment more carefully next time, Rob. Now, Kathy, what if you try the question? Do all stars collapse in the same way?
No, all stars don't collapse in the same way. When a star collapses, it can become either a white dwarf or a supernova. The picture on the left shows a white dwarf, and the one on the right shows a supernova.
Can you tell us some more about white dwarfs and supernovas?
What happens when a star collapses basically depends on the size of the star. If a star is small, it collapses gently and remains collapsed. This is called a white dwarf. In contrast, if a star is large, there's a violent explosion when the star collapses, and the star is blown to bits. This is called a supernova.
What about our sun? What do you think will happen to it? Do you think it'll end its life as a supernova? Rob, what's your thought on this?
Well, I'm not sure, but I think it'll end as a supernova.
You do? Do you agree, Doug?
Not exactly. Our sun is a middle-sized star, so it's probably not big enough to cause a supernova explosion.
That's right. So what do you think will happen to it? One more chance, Rob.
Will it become a white dwarf?
You don't sound too sure, Rob, but that's exactly right. Our sun is expected to end its life as a white dwarf. But we don't have too much to worry about because that's not going to happen for another 5 billion years. Now, even though our sun is most likely not going to become a supernova, let's talk a bit more about what happens when there's a supernova. Sally, how about if you tell us?
Okay, I'll give it a try. When a star explodes in a supernova, it breaks into bits. These bits mix with hydrogen from the universe and form other stars. Our sun was formed in just this way. Our sun was formed from the remains of numerous other stars that had exploded earlier.
Good. I hope you've all understood the basics of the life cycle of a star, particularly of our sun, though I'm not sure all of you do. I'll see you next week for our next session.